In this video, we are going to study simple linear regression in R. As you can see at the bottom of the screen, this is an educational video only and no professional advice is included within it. Okay, so let's go into RStudio. So the first step within the video, which we are going to comment here, is we need to load the corresponding packages. Therefore, step 1 is packages. For this, we use library function, and within it, we have the name of the package. So we'll be using AER package for data, and then we'll be using library function ggplot2 for the corresponding charts. To run these two code lines, we go ahead, select them, and then we click run or Ctrl Enter on the keyboard, which is equivalent. So then we continue with step number 2, which is data. For this, we'll be using data function, and within it we have the name of the data object, which is going to be house prices. This house prices object is located within AER package, and with this data function we load it into the global environment. To run this code line, now what we do is at any part of it, we go ahead and either click run or press Ctrl Enter on the keyboard. As we can see, this creates a house prices object within the global environment as a data frame. And if we click on the spreadsheet kind of icon, this opens the data. And in this video, we're only going to focus on the first two columns of data of price and lot size. If you want to read the full documentation on this house prices object, you can go into the Help tab and search for its name right here by searching house prices, selecting it and pressing Enter on the keyboard. There we are. So there we have the full documentation on house prices object. Then we continue with the third step, which is to do the corresponding chart. For this, we'll be using first ggplot function. We open parentheses and its first parameter, which is data, equals to house prices object we just created, comma, and the second parameter, which is AES, which stands for aesthetics. And we open parentheses again. Within it, we have the first aesthetic parameter, which is x. X is the horizontal axis of the scatter chart with the independent or explanatory variable. Therefore, it's going to be equal to lot size, comma, y, which is the vertical axis, which includes the dependent or explained variable, therefore equals to price. So in this scatter chart, we will have price being explained by lot size. Then we continue with a plus sign and we press Enter on the keyboard. And at the following row, we need to add the dots to the corresponding scatter chart. To add these dots or points, we do so with geom_point. Open and close parentheses. And then another plus sign and we press Enter on the keyboard. And we're going to add the simple linear regression line. To do so, we'll be using geom_smooth and we open parentheses. The first of its parameters, which is method, which is equal to, and within quotations, we have LM for linear model, comma, SE equals to false, meaning that we want this corresponding linear regression line not to include confidence interval. To run these code lines, we go ahead, select them, and then we click run or Ctrl Enter on the keyboard. There we are. So let's go ahead and zoom into the chart. As we can see, we have a scatter chart in which the vertical axis of price is being explained by the horizontal axis of lot size. Then we have the black color points of the scatter chart, and on top of them as an overlay, we have the blue color line with a simple linear regression. So we close this chart and we continue with step number 4, which is the model. And before coding the model, what we do is we are going to comment its equation, which is the following: hat price which is equal to hat beta 0 plus hat beta 1, which is multiplied by lot size. The reason we include hats here is because they are estimates. Therefore, this equation reads as hat price, or the estimated price, is equal to hat beta 0, or the estimated beta 0, or the estimated constant or intercept, plus hat beta 1, or the estimated beta 1, or the estimated slope coefficient multiplied by lot size. So then we press the enter key on the keyboard and we continue with the coding of the model. For this, we're going to create an object named SLR, which stands for simple linear regression, which is equal to, and we'll be using LM function, and within parentheses, we include the first parameter, which is its formula, equals to price, and this with this special character means explained by lot size, comma, data, which is equal to the house prices object we created above, and the following step is at any part of this corresponding code line, we press Ctrl Enter on the keyboard. If you want to read the full documentation on this LM function, again, you can go into the Help tab and search for its name, or also you can go into the console and you can input the question mark LM and without parentheses and pressing Enter on the keyboard. As we'll see, this opens the Help tab and briefly we'll see the documentation for LM function. In order to visualize the estimated coefficients from this linear regression, we can do two things. We can select the object, which is SLR, and press Run or Ctrl Enter on the keyboard, or we can go ahead and input it as well, SLR, and we can press Ctrl Enter on the keyboard. We can also do it directly into the console by inputting SLR and pressing Enter. So right here we have the results from that corresponding regression regarding the estimates for the coefficients. Therefore, first we have here the estimate of the beta 0 coefficient, which is the estimate of the constant or intercept, and then we have the estimate of the beta 1 coefficient, which is the estimate of the slope coefficient. Therefore, this first estimate of the constant or intercept is the estimated price when lot size is equal to 0. And then we have the estimate of the beta 1 coefficient or slope coefficient, which is the estimated change in price when lot size changes in 1 unit. Okay, so now that we finished with the code file, we go ahead and save it. And with this, we finish with this video. Thank you for watching.